All right, here we go. 18.2, the transfer of thermal energy. Hey, when we're done reading this, you should be able to describe the conduction of thermal energy, explain how convection transfers thermal energy, and then give an example of the radiation of thermal energy. All three of these we've talked about before, and we'll talk about them again here in just a second. So, there's a vocabulary we just mentioned, and let's go ahead and start reading. Did you ever cook over an open campfire? The man in the figure below is waiting for his lunch to finish cooking over the campfire. Thermal energy from the fire heats the water. Eventually, all the water in the pot will begin to boil. The man also feels warm from the flames, even though he isn't touching them. Thermal energy is transferred from the fire in three ways: conduction, convection, and radiation. You'll read about each way in this lesson. If you want to preview, you can go to this physics animation video and you can take a look. Conduction. Conduction is the transfer of thermal energy between particles of matter that are touching each other. When energetic particles collide with nearby particles, they transfer some of their thermal energy. From particle to particle, like dominoes falling, the thermal energy moves throughout a substance. In the figure above, conduction occurs between particles of the metal in the pot and between the particles of the pot in the water. The figure below shows additional examples of conduction, the direct transfer of heat. For a deeper understanding, you can go and click on this particular website and watch the animation on conduction. Thermal conductors. Conduction is usually faster in liquids and certain solids than gases. Materials that are good conductors of thermal energy are called thermal conductors. Just like copper was a great conductor of electricity, sometimes there are other materials that are good for conducting thermal energy. Metals are excellent thermal conductors. They have freely moving electrons that can transfer energy quickly and easily. That's why the metal pot in the figure above soon gets hot all over, even though it gains thermal energy from the fire only at the bottom of the pot. In the figure below, the metal heating element of the curling iron heats up almost instantly and quickly transfers energy to the strands of hair that it touches. It's actually right here. Kind of looks like Fergie, doesn't it? Thermal insulators. Particles of gases are further apart and have fewer collisions, so they are not good at transferring thermal energy. Materials that are poor thermal conductors are called thermal insulators. Figure below shows several examples of this. A fluffy yellow insulation inside the roof of a home is full of air. The air prevents the transfer of thermal energy into the house on hot days and out of the house on cold days. The puffy down jacket keeps you warm in the wintertime for the same reason. Its feather filling holds trapped air that prevents energy transfer from your warm body to the cold air outside. Solids like plastic and wood are also good thermal insulators. That's why pot handles and cooking utensils are often made of these materials. Now, some of you may think, oh, hey, listen, if I pack down this insulation, it's going to have more of an insulating value. And the exact opposite is true. It's the air spaces between the fiberglass layers that allows for a greater insulation and therefore what we call a greater R value. All right. Right here we have a little video on the Darfur Stoves Project. Every day, women living in the refugee camps at Darfur, Sudan, must walk up to 7 hours outside the safety of the camps to collect firewood for cooking, putting them at risk for violent attacks. Now researchers at Lawrence Berkeley National Laboratory have engineered a more efficient wood-burning stove, which is greatly reducing both the women's need for firewood and the threats against them. Now, whenever you take a look at this, go ahead and click on it when you're at your desk, and you can watch more of that video. Convection. Convection is the transfer of thermal energy by particles moving through a fluid. Particles transfer energy by moving from warmer to cooler areas. That's how energy is transferred in the soup in the figure below. Particles of soup near the bottom of the pot get hot first. They have more energy, so they spread out and become less dense. With lower density, these particles rise to the top of the pot. By the time they reach the top of the pot, they've cooled off and they have less energy to move apart, so they become more dense. With greater density, the particles sink back to the bottom of the pot, and the cycle repeats itself. This looping of particles is called convection current, and we've talked about this before. It's a circulation of the path of objects due to temperature and density differences. Now, convection currents move thermal energy through many fluids, including molten rock inside the earth, water in the oceans, and air in the atmosphere. In the atmosphere, convection currents create wind. You can see one way this happens in the figure below. Land heats up, cools faster than water because it has lower specific heat. Therefore, land is warmer during the day and cooler at night than water. Air close to the surface gains or loses heat as well. Warm air rises because it is less dense, and when it does, cool air moves in to take its place. This creates a convection current that carries air from the warmer to the cooler area. This sometimes is referred to as the sea breeze, land breeze effect. Air over the land heats up quicker during the day, therefore it rises, so it draws the cool air that's currently over the cooler water inland. So we get what's called a sea breeze. Likewise, at night, the water's been trapping the heat all day long. The air over the water is warmer, therefore it rises. The cold air over the land, or the air over the land, cools down more quickly once the sun goes down. So as the hot air rises above the water, we get a breeze that moves in the direction of the water, which is called a land breeze. Radiation. Both conduction and convection transfer energy through matter. Radiation is the only way of transferring energy that doesn't require matter. Radiation is the transfer of energy by waves that can travel through empty space. When the waves reach objects, they transfer energy to the objects, causing them to warm up. This is how the sun's energy reaches the earth and heats the earth's surface. Radiation is also how thermal energy from a campfire warms people nearby. You might be surprised to learn that all objects radiate thermal energy, including people. In fact, when a room is full of people, it may feel noticeably warmer because of all the thermal energy that people radiate. This is especially true if we're experiencing a tornado drill and you happen to be in one of the bathrooms or in one of the locker rooms with close to 75 people. All right, so in summary, conduction is the transfer of thermal energy between particles of matter that are touching. Thermal conductors are materials that are good conductors of thermal energy. Thermal insulators are materials that are poor conductors of thermal energy. And both conductors and insulators have important uses. We talked about some of those. Convection is the transfer of thermal energy by particles moving through a fluid. The particles transfer energy by moving from warmer to cooler areas. They move in loops that are called convection currents. Radiation is the transfer of thermal energy by waves that can travel through empty space. When the wave reaches objects, they transfer thermal energy to the objects, and this is how the sun's energy reaches and warms the earth. There you have it. If you would, scroll to the top. And in this particular area right here, over here to the side, you're going to see a red button on practice. If you would please click it and click start, and make sure that you reach 100%. Have a great day.